So on the whole, what we're looking for is initially 250 microns or so of central clearance. After approximately half an hour, that may well have dropped down to the 200 to 225 microns of clearance. After about 4 hours, we're down to about 150. The mid-peripheral zone, initially 150 to 175, dropping all the way down to about 100 microns or so of clearance after 4 hours. Limbal zone, that clearance is slightly less, only in the 100 or so microns clearance on initial application, dropping down to being quite close to the limbus, 50 to 75 microns. The edge will need to be aligned with the sclera at all parts of the process. Any lift-off we will need to correct by adjusting the fit of the lens. One of the big benefits of the Onefit Med is that it has laser-etched circles on the front surface of the lens which align with the M and L zones. So it's very easy to see exactly where to make some adjustments. So this is the mid-peripheral line, this is the limbal line. Any changes in the sag will alter the M zone by 50% and the L zone by 25%. Now this is a unique feature of the Onefit Med, producing this linear relationship between the change of sag, mid-periphery and limbus. So if you need to increase the sag, but you don't want to make any changes to the height of the M and L values, you can compensate for this in the fitting tool, just changing the central clearance and leaving the other measurements alone. So let's have a look at central clearance. So the central clearance is the space between the back surface of the lens and the front surface of the cornea at its highest point. When we first insert the lens onto the patient's eye, what we're looking for is a fluorescein thickness roughly equal to the lens thickness, as you can see in this image here. With the Onefit Med, we're able to adjust this sagittal height in 50 micron increments between 3,800 and 6,600 microns. And you can see on the graph how this impacts on the height of the lens above the cornea. If we adjust this sag value, it adjusts the height in a positive or negative way over the whole of the lens. If we don't want to adjust the whole height of the lens, we can adjust the height in the M zone, which is the inner engraved circle. When you look at the front surface of the diagnostic lens on the patient's eye, you'll be able to see the circles. So the M is the inner circle, and this gives us a variation of plus or minus 200 microns. And this is completely independent of sagittal height, L value or H value. So if in this M area you have a protruding suture site on a post-graft patient, then you can lift this area up and keep it away from that delicate area. The markings are also visible on OCT, as you can see in the top image. So on the M zone, increasing that height will increase the clearance, reducing that number will decrease the clearance, and this is over a 9.5mm diameter. The L zone, again, is completely independent of the M zone or the sag. So the L zone is the outer circle. Again, this has a range of adjustment between plus and minus 200 microns. So if we increase that L value, it lifts up that area. Again, decreasing reduces that area, and this is over a 12mm fixed diameter. So it's possible to adjust the M and the L zones together, opposing, to create the perfect profile to fit your complex and irregular cornea. So looking at the image on the left, this is increasing the M and the L values, so we're increasing the clearance overall in those areas, but we're not altering the central sagittal height. Similarly, the image on the right, the M and the L values are negative, so that's reducing the clearance in those areas, again having no impact on sagittal height.